Hello, good afternoon. This is Dr. Shana Mounty, Assistant Professor in Mathematics, Government First Grade College, Jevargi. In the Fourier series, we learned or we known well known about the meanings of odd and even functions. That is, f of minus x is equal to f of x. Then we can say that the function is even. If f of x is equal to minus f of x, then we can say that the function is odd. Related to this odd and even function, we will go for the examples. That is, for the expansion f of x is equal to x square, which is defined in the interval minus pi comma pi. So that means it is an example for the interval minus pi comma pi. This, if we go for the solution, that is f of x is equal to x square and f of minus x is equal to minus x of whole square, that is equal to x square, which is equal to f of x. By this we know that the f of x is even. For the even function, for the interval minus pi comma pi, we know that the Fourier series contains only two Fourier coefficient terms, that those are a0 and an. So that we can write the Fourier series as f of x is equal to a0 divided by 2 plus summation n is equal to 1 to infinity an cos nx. In this series, the two unknowns or two variables or the Euler's or the Fourier coefficients a0 and an, we can define as a0 is equal to 2 divided by pi the integral minus pi to pi f of x dx. For this f of x dx, it is equal to x square. So a0 is equal to 2 divided by pi the integral 0 to pi x square into dx. On integrating with respect to x for the function x square, which is equal to x cube divided by 3 in the interval 0 to pi, that is 2 divided by 3 pi, pi cube minus 0. On solving, that is equal to 2 pi square divided by 3. In the same manner, the an value is equal to 2 divided by pi integral minus pi to pi f of x cos nx into dx. Here the function f of x and cos nx both are positive. Not positive, they are even. So that means we can write it as 2 divided by pi integral 0 to pi x square cos nx into dx. Using the Bernoulli's formula, we can expand the integral, that is 2 divided by pi x square sin nx divided by n minus 2x bracket minus cos nx divided by n square plus 2 times of the sin minus sin nx divided by n cube, which is under the interval 0 to pi. On substituting the upper and lower limit, the values of an, which is equal to 4 divided by pi n square into the bracket pi cos n pi minus 0, which is equal to 4 divided by n square into bracket minus 1 to the power of n. Substituting the a0 value and an values in the Fourier series, we will get it as x square is equal to 1 divided by 2 into 2 pi square divided by 3 plus summation n is equal to 1 to infinity 4 divided by n square into minus 1 to the power of n cos nx, and that is equal to pi square divided by 3 plus 4 into summation minus 1 to the power of n divided by n square into cos nx, which is the obtained value or obtained Fourier series for the function f of x is equal to x square in the interval minus pi comma pi. If we go for the second, the Fourier series for the expansion f of x is equal to x in the interval 0 comma pi and 2 pi minus x in the interval 0 to 2 pi, pi to 2 pi. So that means this is an example for the interval 0 to 2 pi. In that case, if we go for the solution, consider f of 2 pi minus x is equal to 2 pi minus x is equal to f of x. That is, f of x is even in the interval 0 to 0 comma 2 pi. Hence, according to the property of the even function, we know that Bn is equal to 0. So that means for the Fourier series which contains only the two coefficient terms, that is a0 and an. Now in detail we will go for the finding the value of a0 and an. That is, a0 is equal to 2 divided by pi integral 0 to pi f of x dx, and that is equal to 2 divided by pi integral 0 to pi f of x is x into dx. And integrating the x value, we will get it is x square divided by 2. 2 cancel, it remains x square divided by pi under the interval, under the upper limit, it is 0 to pi. Applying the upper and lower limit, we will get it is pi square divided by pi. So pi cancel, only it remains pi. In the same way, the an is equal to 2 divided by pi integral 0 to pi f of x into cos nx. We know that here the f of x as well as the cos are even. So that the an is 2 divided by pi integral 0 to pi x cos nx into dx. On integrating, we get the an is equal to minus of 2 divided by pi n square into bracket 1 minus of minus 1 to the power of n. So that the Fourier series which we can write as f of x is equal to pi minus 2 divided by pi n square into bracket 1 minus of minus 1 to the power of n. So that means only the substitution of a0 and an values. If we go for the third example, which is also an example for the interval 0 to 2 pi. In that case, f of x is equal to x in the interval 0 to pi and x minus 2 pi in the interval pi to 2 pi, and reducing that, pi divided by 4 minus 1 is equal to 1 minus 1 by 3 plus 1 by 5 dash dash. If we go for the solution, let us first find just take the function, that is phi of x is equal to x and psi of x is equal to x minus 2 pi. Phi of 2 pi minus x is equal to 2 pi minus x, and that is equal to minus of x minus 2 pi, and that is equal to psi of x. So that means the function is odd in the interval 0 to pi, and hence for the odd function we know that a0 and an are 0. So that means only thing we have to find the value of bn in the Fourier series. That is bn is equal to 2 divided by pi integral 0 to pi f of x into sin nx into dx. Here both f of x and sin nx are odd function. So that means it is 2 times of the 1 divided by pi integral 0 to pi x into sin nx into dx. And using the Bernoulli theorem expansion, we will get the series is in terms of summation 1 to the power of n plus 1 divided by n sin n pi divided by 2. Substituting x is equal to pi divided by 2 and noting that sine of 3 pi divided by 2 minus 1 and sine of 5 pi divided by 2 is equal to 1. For that we will get, and after expanding or expanding the summation, we will get it is pi divided by 4 is equal to 1 minus 1 by 3 plus 1 by 5 plus dash dash. And if we go for the fourth example, which is related to the interval 0 comma 2 pi, in that case f of x is odd, so for that a0 and an are 0. Only thing, we have to find the value of bn for the Fourier series, that is bn is equal to 2 divided by pi integral 0 to pi f of x into sin nx into dx. Here both f of x and sin x are odd, so that is 0 to pi minus x divided by 2 sin nx dx, and that is equal to, on integrating or by using the Bernoulli rule, we will get the bn value as 1 by n. So that is the series, we can write it as summation n is equal to 1 to infinity into 1 divided by n sin nx. Of course, if you want, take the summation, otherwise leave it. For the expansion of f of x is equal to mod of x in the interval pi minus pi to pi, and show that it is 1 divided by 1 square plus 1 divided by 3 square plus 1 divided by 5 square is equal to pi square divided by 8. F of x is mod, so that means it is a even function, and hence the bn value is 0. If bn value is 0 means the only two terms which is left in the series, that is a0 and an. Let a0 is equal to 2 divided by pi integral 0 to pi f of x dx, 2 divided by pi integral 0 to pi x mod of x into dx, 2 divided by pi integral 0 to pi x dx. On integration, we will get the a0 value as pi, and the an value is equal to 2 divided by pi integral 0 to pi f of x cos nx into dx. F of x is mod, and by taking the expansion or on integration, we get it is 2 divided by n pi square into bracket minus 1 to the power of n minus 1. So that an value is 0 when n is even, and an value is minus 4 divided by pi into n square where n is odd. So that is the function of, or the Fourier series function, which is mod of x is equal to pi divided by 2 minus 4 divided by pi of cos x plus cos 3x divided by 3 square plus cos 5x divided by 5 square plus dash dash. Putting x is equal to 0, we will get the reduced forms, that is 1 divided by 1 square plus 1 divided by 3 square plus 1 divided by 5 square plus dash dash is equal to pi square divided by 8, because we know that cos 0 is 1. And these are some references that are used for the solving the examples. Thank you.